Type 1 and Type 2 errors. These occur with the hypothesis testing, and it is covered in section 9.4 from our textbook. But Type 1 and Type 2 errors, there's a total of 4 possible outcomes from our hypothesis testing. The first is to reject the null hypothesis when the alternative hypothesis is true. So, that being this particular box down here. That creates a correct conclusion, right? We want to reject the null hypothesis when its alternative is true within the population. So this is a correct conclusion down here. The second one being, do not reject the null hypothesis when the null hypothesis is true. Again, we don't want to reject the null hypothesis if the population shows it being true there afterwards. So that's also another one of those correct conclusions. The first type of error that we could have in this type 1 error, that occurs when we reject the null hypothesis when the null hypothesis is actually true. Okay? And that's referred to as a false positive. So, in another sense, if we have, for example, let's say a drug testing, they try to test to see if we have a drug, and this the test itself claims that you have the drug, but then the drug in your system, but then further testing shows down the line then you never had the drug at all in your system. That would be an example of a false positive, right? Well, we reject the null hypothesis, in this case that you have the drug in your system, but the alternative is actually true in my scenario, meaning you do not have the drug in your system. A type 2 error is when we do not reject the null hypothesis when its alternative hypothesis is true. That being this cell up here. The type 2 error, that's referred to as a false negative. So using my same drug testing scenario, that would be where we claim we do not have the drug in our system after the test, right? So that means we do not reject the null hypothesis. So we claim we don't have that drug in our system, but then further testing down the line shows we really do have that drug in our system based upon this alternative hypothesis. But just like with confidence intervals, we do not know if the conclusion of a hypothesis test is correct. So we could assign probabilities to these type 1 and type 2 errors. A type 1 error, again, probability of rejecting the null hypothesis when the null hypothesis is actually true, is alpha. And alpha, as we've seen with hypothesis tests, is our level of significance. And again, we could give that the interpretation of the probability of making a type 1 error. This is chosen before the sample data are collected, and it depends on the type of consequences that we wish to have. Right? The most common one to use is a level. That was not supposed to erase. Most common one is a level of significance of 5%. Which now I cannot get back on here. But anyway, level of significance of 5%. So that just refers to a level of significance being 5% for this. As I try to get that back up on here. That's the most common one. It's when we have a level of significance being 5%. The other ones that we can have, a confidence level of 90%, that's where we have a 10% level of significance, and a confidence level of 99% when we have a level of significance of 1%. So then you may be wondering to yourself, well, especially with like drug testing and whatnot, why would we be more likely to use this 95% one? That's because we have this indirect relationship between this type 1 error and then the type 2 error. Okay? So the type 2 error, the probability of that is the probability of not rejecting the null hypothesis when the alternative is true. And that's referred to as beta. And beta, if we have a low value of the level of significance, that indirectly, and it's not an exact calculation, but indirectly it causes a large probability of a type 2 error. Likewise, if we have a high level of confidence, we have a low probability of type 2 error. Okay, so high level of significance, low type 2 error. So what that means then is that for the significance level of 1%, that would then mean our type 2 error probability is high. For a level of significance of 10%, our type 2 error probability is low. But then our level of significance is kind of high then, which is why 95% is used a lot. 1% is used more with regards to drug testing and whatnot.